I want to show you a method for factorising a quadratic of the form ax squared plus bx plus c when the coefficient of x squared is greater than 1. And before I do that, I just want to show you a couple of things which you need to understand in order to understand the method. So first of all, you need to understand how to use the grid method for multiplying out two pairs of brackets, where in each bracket there's a linear expression in x. So here we've got a pair of brackets. First one is, the first term in it is x, the second term in it is plus 3. So we put them on one side of the multiplication grid, and the same with the other brackets. So we've got 2x as the first term and minus 5 as the second term. So for both terms in each bracket, we need to multiply them by both terms in the other bracket. So we multiply the x by the 2x and the x by the minus 5. And then we need to do the same for the 3 times the 2x and 3 times minus 5. And so we can simplify what we've got by combining like terms, which gives us the 2x squared, 1x minus 15. So we've used the grid method to multiply out those two pairs of brackets. The second thing you need to understand is how to factorise a quadratic just in the form of x squared plus bx plus c. And so we do that by finding a factor pair of c whose sum is b. So on our first example here, you can see that the value of c, the constant, is 56. So what we need is a factor pair of 56 whose sum is 15. Now we're going to write out the pairs of brackets ready to write the numbers in. It's a quadratic whose the coefficient of x squared is 1, so we're going to have an x at the start of each bracket. Now we need to know the factor pair of 56, which sums to 15x, and of course that will give us 8 and 7, whose product is 56 but whose sum is 15. Doesn't matter which way round they go, but those two values go in those two brackets. Second example, again we need to find a factor pair of our constant, which now is minus 3, whose sum is 2x. It's just one lot of x squared, so the first term in each bracket will just be x, and of course the two numbers are 3 and minus 1. That's our factor pair. Again, doesn't matter which way round they go, but there we've factorised the quadratic where the coefficient of x squared is 1. Right, now we're ready to factorise a quadratic where the coefficient of x squared is an integer greater than 1. And the way to do this is to find a factor pair not of c but of a times c whose sum is b. We'll have a look at how to do that. And we do it using a grid. So for our first example, we can see our value of c is 3, so a times c is 10 times 3. And what we're looking for is a factor pair of 30 whose sum is 17. And of course the factor pair is 15 and 2. Now what we're going to do now is we're going to fill in our multiplication grid that we would have used for expanding brackets. Then we're going to work backwards. We know that our two values in x go in those two squares in our multiplication grid. They need to add up to 17x, and this has given us what those two will be. It doesn't matter which way they go round, but we'll put the 15x there and the 2x there. Now we know when the brackets have been multiplied, we know what our constant is, that goes in this square here. We know what our term in x squared is, and that goes there. So we're doing the reverse of multiplying out two pairs of brackets using the grid. So now what we need to do, we need to find the constant here, and that constant will be the highest common factor of those two terms. And so that's going to be a 3. And similarly, we can look at these two and say what's the highest common factor, but we can also say to get our value of 3 there, we've got 3 times what's the factor pair. And of course, either way we get 1. We can now look at our 2x, and we know to get a product of 2x we must be doing 1 times 2x. For our 10x squared we must be doing 2x times 5x. Similarly, we could look at the 15x and say 3 times 5x gives us 15x. So either way we get our 5x there. And so here's one linear expression, and here's our second linear expression. We've got 2 linear expressions which multiply together to give us the quadratic we started with. I'll do one more example, and here we've got